What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this quick little video, you're going to learn about wired network troubleshooting as it relates to bad cables or connectors, bad ports, opens and shorts, splitting pairs in a cable, decibel loss, transposed, transmit and receive leads, cable placement, exceeded distance limitations, crosstalk, speed and duplex mismatches, and transceiver mismatches. Let's talk about bad cables or connectors. So faulty cables with electrical characteristics preventing a successful transmission, or faulty connectors which do not properly make a connection. They can prevent successful data transmission at layer 1. A bad cable could simply be an incorrect category of cable being used for a specific purpose. Bent pins in a connector or incorrect pinouts, they could also cause issues. So make sure all your cables are good to go and you don't have any bent pins. Next, we have a bad port. So a port may be bad on your network device. Oftentimes, you can easily confirm this by using the network connection LED and status indicators. So you check those, make sure the lights are doing what they're supposed to be doing. If not, you may have a problem where you might want to clean out the port, or if possible, you may want to swap that port out with another functioning port, if possible. Next, let's talk about opens and shorts. So an open, this is a broken strand of copper preventing current from flowing through a circuit. However, a short occurs when two copper connectors touch each other, resulting in current flowing through that short rather than the attached electrical circuit because the short has lower resistance. Then we have splitting pairs in a cable. So an unshielded twisted pair cable consists of 8 separate copper leads. However, only 4 of those 8 leads are used for data, 2 to transmit and 2 to receive. This results in 4 unused leads. Some installers use those 4 extra leads to support a second Ethernet connection on a single untwisted pair cable. Although such an approach can function, non-standard wires are being used for connecting the second Ethernet connection. Therefore, you should be aware of any non-standard pinouts used in the network that you are troubleshooting. Then we have decibel loss. So the signal power of a data transmission might be degraded to the point where the transmission is not correctly interpreted by a receiving device. This loss of signal power, called a decibel loss, could result from exceeding the distance limitation of a copper or fiber cable. Then we have transposed, transmit, and receive leads. So some Ethernet switches support medium dependent interface crossovers, or MDIX, which allows a switch port to properly configure its leads as transmit or receive leads. You can interconnect such switches with a straight through cable as opposed to a crossover cable. However, if a network device does not support MDIX, it needs an appropriate cable or a crossover cable to allow its transmit lead to connect to its receive lead on a connected device and vice versa. Therefore, care must be taken when selecting cable types, interconnecting network components. Then we have cable placement. So because copper cables are subject to electromagnetic interference, you should arrange cables to minimize interference. Ideally, Ethernet cables should not be placed in close proximity with high voltage cables, generators, motors, or radio transmitters. So for example, when running cables between buildings via underground conduit, you should ideally place network cabling in a conduit separate from the electrical cables. Then we have distance limitations are exceeded. So if Ethernet devices are interconnected using a cable that exceeds the Ethernet distance limitations for the cable type, a digital transmission between those devices can be degraded to the point where the receiving equipment is unable to correctly interpret the transmission. Attenuation is the technical category for this problem. Therefore, a network design should consider distances between devices. Then we have crosstalk, and this can occur when an analog connection creates an electromagnetic field around its conductors, inducing its waveforms on a nearby analog connection. This phenomenon is most commonly experienced in an analog phone call. Crosstalk can be minimized by using a higher category of cabling, because higher categories of cables better limit the radiation of electromagnetic waves. Next, we have speed and duplex mismatches. So speed and duplex mismatches, they can be tricky to troubleshoot in a network, especially considering that connectivity is often maintained just at unacceptable levels. And then you have a transceiver mismatch. And transceivers, they must be selected carefully to ensure compatibility with the cable type and wavelengths that are in use. All right, so that was my quick little class on wired network troubleshooting, where we talked about bad cables or connectors, bad ports, opens and shorts, splitting pairs and cables, decibel loss, transposed, transmit and receive leads, cable placement, exceeded distance limitations, crosstalk, speed and duplex mismatches, and transceiver mismatches. Now, if you felt like you've gotten something valuable out of this information, go ahead and leave a comment, hit the like button, share this video, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.